Now right here we have our diagram that shows our task for today. We shall be creating a VPC with a subnet, and inside the subnet we shall install EC2 and then create a Jenkins server from the EC2 instance. So today we have a prerequisites for today. You must have AWS CLI installed and configured, and Terraform also installed. So we shall create a VPC, a subnet, an internet gateway, a route table, route table association, security group. We launch an EC2 instance, and we shall use a script to install Jenkins. After that, we shall log into Jenkins through the public IP of our Jenkins server, and we shall view it on the terminal. We shall view a live Jenkins server on the terminal. So that's the plan for today. Okay, so let's go through, create Jenkins server, and we shall access it through our internet browser. Okay, so now let's begin, and we should create a provider.tf file, which will hold our provider for our Terraform code. We're working with AWS, so I'll just paste the one we've used earlier in our provider.tf file. That's AWS. Now, previously we were hard coding, but now I'll create variables so that we can be more efficient and we can reuse the code. So I'll create a file called variable.tf, and we shall turn our hard coded values from the previous exercise into variables, which is just more efficient when it comes to writing code and reusing code. So there, I will change this to a var.region. So I'll create a variable called region. So var.region, and then I'll go to the variable.tf and create that variable called region. So there we have the variable. We'll name it region, same name as the one we created, on the other file, and we'll set the default value, which is the value we want it to have. So it was user US East 1, remember? Yes, US East 1. So we can save that. So now we have set a variable rather than hard code. So in future we can just change the values in the variable.tf file rather than go into the main source code. Okay, so that's done. So we create region has been made a variable. So that's how you do it in Terraform. Rather than hard code, we just use variables instead. Okay, I hope you understand that. We took out, the US East 1 as the region, and we created a variable called region, and then replace it with that. Okay. So next, let me just clear the screen, okay, so you can see better. Okay, and then we'll go to the networking directory, networking file. We'll create that, and then we'll put in our VPC with the subnets and the internet gateway and the whole networking we had in the previous exercise. So the cider block is hard coded. We can also change the cider block into a variable. So let's cut this out. We'll cut it out, make it var.vpc cider, because it's for the VPC, so we can differentiate from the subnet cider. So variable.vpc cider, and then we'll go to the variable.tf and create the variable VPC cider and give it a value, which was 10.0.0.0/16, if you remember. VPC cider, yes, and give the default value, which we had in the networking.tf file. There. Okay, let's save this so we don't lose it. So now we have another variable. Okay. Now let's go for the internet gateway, which is the next one we had in a previous exercise. The internet gateway. Hold on a second, please. Just get to that now. I'm just cutting and pasting from my previous exercise. So if you haven't watched the previous one, you can go to a channel and you would see how to use Terraform to create a simple web page. So there, the cider block as well needs to be variabilized. So we'll take that out. We can call it var.subnet cider. So we can differentiate from the VPC one, subnet underscore cider. And we shall now go to variable.tf and make the default 10.0.1.0/24 as before. Subnet cider, and the default will be the value we cut from the networking.tf page. Okay, so that's done. Yes, that looks good. So what's next? Hold on, please, while we get the next to be done. The internet gateway should be next. This looks fine. There's nothing to make available here, so that's fine. Let's go to a route table now, the route table, and see if there's anything that we can change to variables here. Okay, I'm going to paste this here. That's a route table. That looks fine too. It's already, there's no hard code in here except the tag, which we can always do later, but that's easy and straightforward. Let's check the routes. If anything to change here at all. I'll just paste the route here. Let's see. Okay, the cider block, that could be made a variable. We don't have to, but just to show you how this can be done. So I'll cut out that. It's just 0, 0, 0s, open to everywhere. I'll cut that out and make a variable here. So let's cut. Then var.destination cider block. Remember, it can be anything. We can call it variable anything, but we have to use the same name in a variable.tf. So variable.tf, let's create a variable called default. The default destination cider block, yes. And the default will be 0.0.0.0/0 as we had in the networking page. Yes, so that's that. Okay, let's go back to our networking.tf. Next, we can do the route. What is left? The route table association. Okay, it's nothing to make a variable here. Nothing is hard coded, so we don't have to touch. And that's in the wrong place. We need to cut it and put it. No, that's the networking. Yes. Okay, so there's nothing to make a variable there. Okay, so we can save this. I think that's all we need for the networking. If that's done, then we need to create the security group.tf. Security.tf, which will have a security group and the rules. So let's clear first of all, so we can have enough space to see what's going on. Okay, we can touch security.tf. That will create the security.tf Terraform file that will contain the configuration of the code for the security group. Yeah, there. Okay, yes. And let's paste that security group. Yes, there's nothing really to hard code here. Let's just change this prefix to something less than 3, so you can see the less than 3. Yeah. Okay, let's get the rules. The security group rules. Remember, we need to have rule 80 for HTTP, rule 22, so that we can log into the instance through SSH, and we need rule 8080 ingress 2, so that we can use Jenkins. That's the Jenkins port, and then we shall also open the outbound to everywhere, so that we can download patches and install a clone from the internet. Okay, so let's look at the rules. Also need rule 22 SSH, because at the end we're going to have to go into the instance from the terminal to get the password for Jenkins, which we shall use later. We're going to cut into the particular folder in the instance when Jenkins has been installed. So yes, 22, and then we need to open the Jenkins port. That's port 8080. Without this, we will not be able to use Jenkins if that port is not open, because that's the Jenkins port. Okay, yeah, let's put this there. We need to attach it to the security group. Yes, that was missing. Okay, so now we have port 80 HTTP done. We have port 22 SSH done. Now we need port 8080 for Jenkins. That's going to be the next one. So let's do port 8080 for Jenkins. Hold on, let me grab that. Yes, that's the Jenkins port. So our Jenkins can work and can be reached from the browser. And let's not forget our egress rule, or outbound rule, which we shall need to enable our instance to be able to download patches, updates, and even clone things and copy from the internet. Okay, we'll assign that there to the instance, to the security group. Let's get that saved. And ladies and gentlemen, that's all we need for our security.tf. That's done. Security is done. Next will be our ec2.tf. Remember, it can be any name. I just name it ec2 so we can know that for the ec2. We're going to create our ec2 instance now, the data sources, and most of all, we're going to use a script that will automatically install Jenkins onto our instance. Okay, so that's created the ec2.tf. Now let's begin the post. First of all, remember, we need an AMI, Amazon Machine Image. So we use a data source to automatically grab it from the internet based on the filters that we specify. We specify the AMI name and the owner. Our owner, we've used Amazon. Amazon is the Amazon ID is the one at the bottom, the 0997, the long number there. That just specifies Amazon and Amazon AMI. So we'll grab it from there, and then also we'll need a key pair. I'm using one that I already have on the computer, so it's already created in AWS. So we're assigning that to key name, which we shall use in our instance. That will help us when we want to SSH into our instance. Okay. Yes, I already have that in my download folder, the private key, so when I run in download folder, I can access into the EC2 instance once it's been created. Okay, now this is our script that does the work. So now you can see, okay, this is the instance. Let's call it name something different. Jenkins server. Let me call it Jenkins server. Okay. Now the AMI we've grabbed from AWS. You can see through the data source. The key name, we've assigned it to the key name we have there. We've used the security group we created. Now this is the data script that does the work. So we update the package manager. We install the Java. You need Java for Jenkins to work. So we install Java there. After installing Java, we now download the package manager Jenkins package and key, which is needed to install Jenkins. After that, we install Jenkins with that line, and then we start Jenkins and then enable it. You enable Jenkins so that if the instance is stopped, once it's restarted, it will automatically start again. So that's the code we need to have our instance with Jenkins installed and up and running. Okay, so let's save this, and yeah, the code looks good. I hope you understand this. If you don't, you need to watch this again, but it's quite straightforward. It's quite straightforward. So once we run our Terraform code, it will, okay, let's check our instances. You can see now we have no instances running. Let's go into instances. This is our terminal AWS. You see there's no instances found. So we have no running instance, but by the time we run our code, you would see that the instance will be created. The Jenkins server will have been created, and also it will have automatically installed Jenkins and everything else we specified in the configuration. Also, we'll have installed our VPC, internet gateway, subnets, the route table and routes, all the networking, everything will be done automatically by running the Terraform code. Okay, so let's clear this again so we can see properly. Okay, let me move this up so we can see what is going on right in the terminal. Okay, now let's initialize our working directory running Terraform init. That will initialize, it will download all the plugins Terraform needs to communicate with the AWS API. Okay, very important. So that's all the provider plugins, any module plugins, models. It will initialize the backend, everything else. So that's happening right now. It shouldn't take that long. It's initializing. Okay, successfully initialized. Let's clear. Now I'll run Terraform validate. You don't have to do this, but I like to validate my code first. It just checks for syntax errors, minor errors in your code. Just syntax errors mostly. I like to know that's fine before I begin to plan and apply. Okay, so it's checking. It's valid, so that's fine. I have done that well. Let me clear. So now let me run a plan, which is a dry run, to show you what you intend to create, what our code will create. What infrastructure will be built. So it's planning now in the background. It will show us, give us a list of what is going to be created. That's building. Okay, says the plan 12 to add, 0 to change, 0 to destroy. So it's going to create 12 things. Now let's apply. Now apply, we actually go there and create the infrastructure. Terraform apply, we shall use the auto approve option so that it doesn't ask us if we are sure to do this. It will just automatically approve and go right through non-stop. So let's run this and watch as our infrastructure gets created. This is the beauty of Terraform. You know, just spend the time writing the code and just, you know, rest, take a chill and watch the magic happen. So it says plan is 12 to add. Okay, now it's going to start building, creating now. Now you can see it's creating VPC, internet gateway, route table being created. Security groups being created. You can see that instance being created. It's doing everything. Okay. Now, how long this takes really depends on the complexity of your whole infrastructure. You know, if it's just a few things, few resources, it wouldn't be that long, a few minutes. But it can go as long as possible, depending on the number of the complexity. Things like creating containers and Kubernetes take even much longer. You know, but this is so apply complete, 12 resources added, 0 change, 0 destroyed. So we can go to the console and just check to see if our instance, remember it was called Jenkins server. Let's see if it's been created, you know, from just this code. So yes, there. So we're going to instances. Let's refresh this and see if Jenkins server is now created. It's loading. Yes, let's check it. Instance latest. It is there. And it's running. It's running. Check. It's running. So there it is. We have our instance created and everything installed, but we have to test to see if it's going to work. So we need to grab the public IP of our Jenkins server, which is the instance, and then go to a browser on port 8080, which is Jenkins port, to see if we can see our Jenkins. So we create the paste that and colon 8080. Yeah, that's the Jenkins port. And run and see if, yeah, it looks like it's good. Oh yes, now we have actually installed Jenkins successfully and we can view from the web, but we still have to configure. We need the password, so we're going to copy this and we shall use the cat command on the terminal to go into this to retrieve the initial password. Once you've done the password, you can now change it to something more secure. It's just the initial one, you know. So we go to the terminal, we go into our Jenkins. Okay, permission denied. We need to use sudo because it's super user password. Okay, now that's the password there. We'll copy this, go back to a browser and enter this as the initial Jenkins password. So let's go back to the browser and use this password to log into Jenkins. We can change this later. It's just the initial admin password. Just paste this there and click continue. Yes, install the plugins. So it's the plugins, select that. Now it's installing some of the plugins we need for Jenkins. You know, with Jenkins you can always add more plugins once you're into it. You can go into settings and add as many plugins as possible, depending on the project or the use case. So you can see things like Git, LDAP plugins, Gradle, Java. You can see things like pipeline, stage view, different things there. So create your first admin user. I'll just use admin because we're just testing. In the real world, we use something much more secure. I'm just using admin here just to do this quickly. Okay, you always go for very secure passwords. Let's make up an email here just to do this, to go past the stage. I'll just make up the email. Doesn't really exist. Okay, and save and continue. Okay, so save and finish. Yes, now Jenkins is ready. So now we have successfully installed Jenkins, yes, and viewed from the browser. So that's the project all done. So now you know how to install Jenkins with Terraform. You know, it's a very effective way rather than having to go through the control panel or have to SSH to install. So ladies and gentlemen, we have done this in no time at all. Okay, so now let's check to see our resources. I'll show you a new Terraform command. You can use Terraform state list. It will list the resources we have created through Terraform. So Terraform state list, sorry. Yes. So we can see our resources. They will come up, and we can see what we've built so far. These are what we've built for our project today. Okay. Now remember, you need to destroy after the project because it costs money. So if you leave it there, you'll be hit with a bill. So let's do Terraform destroy to destroy resources that have been created. I'll use the auto approve again so that it will destroy without asking me to verify the destroy. So run this and let's destroy the whole infrastructure. So let's destroy this to avoid costs. And surprises. Now, refreshing and being destroyed. Yes, it's going to destroy 12 to destroy, which is what we want. Still destroying. Shouldn't take that long. Destroying is a bit more, it's a bit, I think, faster than creating. So when you create with Terraform, always make sure you destroy with Terraform. Don't make the mistake of trying to go into the console to destroy manually, because then you'll break the whole, you'll break the Terraform script. Okay, so now let's use state list to see if, since all destroyed, to see if anything's left. So Terraform state list, hopefully nothing to come back. If nothing comes back, it means everything's been destroyed successfully. Just a test. Yes, nothing's come back. So we have indeed destroyed all 12 resources that we created. So let us go to the terminal and see if our instance is still there. We should also check to see if Jenkins is also still there. Let's go to the terminal first. Yes, a good instance. Hopefully it should be terminated right now. Refresh. Yes, you can see it is terminated. So that has worked. We have terminated the instance. So there'll be no surprise costs building up. Now let's go to the Jenkins page on the browser. Let's refresh. This should time out because the server is no longer available, has been destroyed. So let's check and see. Let's wait and see. Refresh, waiting for it. It's spinning, it's doing something. Let's see. It should time out. Yes. Error connection timed out. So it cannot be reached. That's because it no longer exists